Hello, this is Kai. Welcome back to Programming Methodology Assignment Solutions. So we're now on assignment number 1, problem 2, and problem 2 is called StoneMasonKarel, as you can see here. Here what you have is a world where Karel needs to repair the world by building columns. Notice how these columns, which are made of beepers, are partially destroyed, and so Karel needs to go to each column and rebuild it. And so, as you can see at the final box, that all the columns are wonderfully built, and Karel has done his job. So, what we're going to do is we're going to go ahead and get started. The thing here is, compared to the other video, now in this video, you should already know about a couple things. Like, for example, going back to our little cheat sheet, you should know that Karel has something called conditions. Basically, when it's clear, when it's blocked, if it's facing north, facing east, or if there's a beeper present, or if there's no beeper present, you have to go ahead and use all these methods right here. Now, you don't have to use every single one of them, but definitely over the course of the programming methodology class, you will go ahead and have your own favorites that you'll use time and time again. And I do have my own favorites, and I will show you a trick or two in this video. Okay, so we also have something called conditional statements, which are if statements. They come in 3 types. One where you have the if condition with one body statement, which you don't need the curly brackets for, but if you have multiple statements, you do need the curly brackets to execute all those statements. You can also have something called an if and else statement, where if something were to happen, you would execute that, or else then you would execute that. So that's also nice. And here they didn't put in, but you also have something called if and else if. In terms of iterative statements, you have something called a for loop, which executes a certain number of times, and you also have a while loop, which executes as long as the condition is being met or not being met, depending on how you make it. And then here we go down to the nice little thing right here. This is called SuperKarel. As you can see from the StoneMasonKarel Java file that I just opened, you imported the same old Java package for Karel, but you have something that's a little different. You have something that extends as SuperKarel. Well, SuperKarel does everything that Karel does, but it also does these 3 things. So Karel can now turn right, turn around, and paint a corner. And if you remember from our last video, being able to turn right was a little bit of a problem for Karel. So now that SuperKarel is here, we don't have to worry about that. Okay, so the first thing that you want to do is you have to go ahead and be able to design your program. Now, it would be in your best interest to start early on a top-to-bottom methodology way of designing the program, because if you try to go from small bottom to top, it might get very complicated. You kind of want to know what you're going to be building in the first place. So, first of all, what you'll always need is you'll need your public void run method, which will run the program. And in this public void run, we are going to go ahead and create a method where he will build the column. Okay, so building the column is important. So he's going to turn left, and he's going to build it. Now, once you build the method, we need to create a stub for it. So you can choose private, public. It really doesn't really matter at this point, but for now, I'm going to go ahead and keep getting practice putting private, because you don't want it to interact with other classes, considering that later on in the course you will have classes interacting with classes, and it can complicate it if you have similar names for everything, or the same names for everything. But anyways, we're creating a private void build column. That's a stub because it's the method, but we haven't really put anything in there yet. And then once we build the column, we need him to come back down. So we're going to say move back down, because we want him to move back down. Again, associate that also with a stub for private void move down. There we go. Good. And now we need him to be able to move across after he moves down. So after he moves down, we want him to move across. There we go. Boom. And don't forget to create that associating stub for that as well. So private void move across. Nice. Okay. So this is what we call top bottom, where you have an idea of what you're going to make, and then once you do that, now we go ahead and build each and every one of them. So let's start with build column. So as you can see here, the first thing you want him to do is you want him to turn left, right? So he turns left, and then what? Well, first thing is, he's in the column, right? So he has to check to see if there is a beeper. So this is where we use our little condition that we talked about, and as you can see, we want to check if there is a beeper present. So if there is no beeper present, what do you want him to do? Well, let's see. If no beepers present, then what we're going to do is we're going to go ahead and put a beeper, right? Because if it wasn't there, the whole purpose of StoneMasonKarel is to rebuild those columns. So no beepers present, put a beeper. And so after he places that beeper, we want him to go ahead and move. Now, I know it's just simple to go ahead and count, check beeper, move, check the beeper, move, and you can do it 1, 2, 3, 4 times. You can hard code that, but we want to build a program where it can handle many different situations, okay, in many different scenarios. So here, instead of having it hard coded, this is where a loop comes into play. So what you should use is a while loop. A while loop is a conditional type of loop where you can check the condition if it's still existing. For example, while he's moving up, right, you want him to keep putting beepers down if there's no beepers, and you want him to move. So we want to check to see if his front is clear. Okay. So since, and as you can see in this execution, since he's turned to the left and he's facing upwards, since his front is not blocked, it will execute this loop. So since his front is clear, it will check to see if there's beeper, move. Clear, check beeper, move. Clear, check beeper, move. Clear, check beeper, and then move. Now once his front is blocked, right, this is where the loop will finish its execution. Now the problem here is that once the loop is out, we haven't checked that spot yet. So what you want to do is make sure that Karel will check that spot as well after the loop is done, so that he can see if there is a beeper there or not, and if there isn't, he would place a beeper there. And notice how it's nice and clean, build column. Just that little algorithm explains how to build the column in the first place. So boom, that's done. Next, what we want to do is once he's done building, we want him to be able to go back down, right? So what we want to do, and the nice thing here is we want him to turn around, right? So turn around, and then we want him to move. And again, you don't know how many times he's going to move, so the smart thing to do is we want to go ahead and stick this in a while loop again. So while, and checking that his front is clear, we want to be able to move down. And once he's moved down, let's go ahead and have him turn in the appropriate position. So turn left, so now he's facing towards the east again, okay, in that same position. So moving down is just turn around, and then checking to see if the front is cleared, and then he's going to move. And he's going to keep moving until he's blocked. Once he's blocked, he's not going to move. Rather, that whole while loop will complete itself, and then he's going to go ahead and execute a turn left. And just like that. And then we have to finish our last method, private void move across. You can see here, this is going to be standard for all maps, but he is going to be 4 spaces away. So we could code move, and we could do it 4 times, like so. So that would be okay. But if you want to use your newfound knowledge, we can also use something called a for loop, which works a certain number of times. The way it works is we first have to initialize a variable, integer, and we set it to 0. And basically we want it to work 4 times. So I is less than 4, and then after it does it, we want it to increment by 1. Okay, so there you go. We create a for loop that would increment 4 times. And what do we want to do 4 times? Well, we want them to move 4 times. So instead of having these 4 move methods, we're going to go ahead and make it into 1 and use only a for loop. Now, the benefit, you might say, well, geez, that's just as much typing. Why in the world would I go ahead and change my 4 move statements to a for loop? Well, imagine that it's not just for 4. Imagine that it's 16 or 18 or 20. Are you going to have it executed 20 moves like 4 times in 4 sets? No, right? That's kind of stupid. So we're going to go ahead and stick it in a for loop so it's nice and clean. And also, if you also have to make some modifications, just pop it right there and it's going to go ahead and execute it with it. So you wouldn't have to write it down additionally as many times as you need to. So that's a nice thing about a for loop. And then once you have it move across, it will go ahead and execute. Now the only thing here is we have him go build the column, move down, and move across. But he only does it 1 time. So what do we need to do? We need to put in a while loop, right? And this is one of the tricks I've learned doing this. The nice thing to do is, if you put a while loop, you don't know how many times he's going to do it. So we're going to go ahead and put something called while true. Now, true is like a little trick. Basically, it checks to see how many times you want to do it, but since it's true, it happens forever. So it just keeps going and going and going. And the cool thing, the thing that you want to do is that you want him to keep going until once he gets to the end, which is the last column of the whole entire thing. In this case, you want him to stop moving. So the best thing to do is once he builds a column, let's go ahead and check to see if the front is blocked. So if front is blocked, what we want to do is we want to break. So what this does is that once he's done building and he turns around, he's going to check to see if his view is blocked. And if it is, it will break out of this while statement and it will execute the problem, the program. And so what would happen if you didn't put this break, right? Well, let's see. If you didn't put this break and I executed the program, basically he would, there he goes, look at that, perfect. You see this little box, it would say Karel is blocked, and so that's because the next thing he was supposed to do is move across. But if you were to put in the statement, and you don't have to, but if you were to, and run again, the nice thing here is that once you run the program once, you can hit the faster running man and it'll execute the same program, and you'll see that oh, whoops, okay, maybe it wasn't a good idea to put it there. What would we need to do? Oh, I stuck it in the wrong spot, that's why. He needs to move down before he moves across, right? So that's silly me. Okay, so basically we put it after the move down and hot swap it again. There we go. Start the program, boom, 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 look at this, and done. And look, there is no red box that says that Karel is blocked, if you just don't like seeing that red box there. Now, the thing is that we want to make the program generic enough so that if we were to put in different worlds, let's say this one, see how it's all funky and stuff with different heights and different stuff, it would still run perfectly, see? So the purpose of making your algorithms general is in your favor, so you wouldn't have to keep going back into your program to change things out. And that's how you do problem number 2. Now, if you like this video, please like and subscribe, and yeah, it will show some support. Thank you.